Hey, what's up guys, my name is Cherno. Welcome back to my Game Engine series, day 4 of Game Engine series week here today. And today we're going to be doing some pretty exciting work. We're going to be adding serialization and deserialization to Hazel, meaning that we can actually, by the end of today, save our scenes out into a file and also load them. So that's going to be pretty exciting because at the moment we're creating our entire scene through code, and if we do anything, if we actually create anything with Hazel or with Hazelnut, which we're able to do now, using all the new UI that we've added, such as the add entity, add component UI, all of that stuff from the previous episode, which I will link up there. Now that we can do all of that stuff, it would be really nice to be able to save that to a file so that we can save our work, because not saving our work obviously is really annoying. So that is what we're going to be doing today. Let's dive right into the code. We've got a lot of stuff that we need to do. Let's take a look at it. Okay, so as always, I've got like I've got the code over here, and I want to mention that for this episode, even though I feel like some people probably won't like this too much, I am actually going to be copying and pasting code that I've already written. The reason is that the actual Serializer code that I've written is like 250 lines, that file, so I don't want to type it all out in front of you. I will incrementally copy and paste it and then explain it as well so that it makes sense to you, but a lot of it is just normal kind of boring serialization code that we just need to get through every field of like the camera class, for example, and actually serialize it. So hopefully like the important stuff will still be explained and it will make sense. So I guess the first question is, how are we going to serialize it? Well, there's two different, I've talked about this before, but there's two different ways to serialize. There's the kind of text format that we want to use for production. So when we're actually working on like a game or a project using Hazelnut, we want to serialize our scene into a text file. The reason we don't want to use binary for that and we want to use text for that is because we want it to be human readable and possibly more importantly human mergeable, meaning that if two people work on that same kind of scene file and they both, like, let's just say, add one entity each, we want to easily be able to merge that together just using like a git like merge tool or something like that, right? We don't want to actually have to, create some weird binary tool that's going to manually, merge all those bytes together. That's awful. We don't want to do anything like that. We just want to have normal text file format. And we specifically, I've chosen YAML for our text file format because it's really easy to read and more importantly, really easy to merge. So if you actually go to the YAML website, it's entirely written in YAML. This is all YAML compliant, where you see all the text here. And as you can see, it's really easy to read. JSON, on the other hand, is not that easy to read, and it's a lot harder to merge, because anytime I've had to merge JSON in the past, there's always like some curly bracket that I missed or something's misaligned, and because of that, it just becomes really super annoying. Because, well, something's gone wrong and now I have to go back and trace all of it's a disaster. This is really easy. There's no weird brackets here anywhere. You can see that we have like, key and value pairs, like in a map. We've also got arrays, which are dot points, which is just so easy to read. So I really do like YAML, and that's the format that we're going to use. And it's used by Unity as well. So it's obviously not something that's very obscure. Now, as always, I've created a little fork of YAML CPP, which is the library we're going to use for this. I'm not too concerned about performance here because this is just for like loading and saving scene files and possibly any other kind of production like data, right? This is not something that we kind of use for, something serious like runtime code where like, we want it to be like as fast as possible and we care about performance. No, this is just saving loading scenes, right? So not too concerned about performance here. There might be a faster YAML library out there. I've been using this one for a while in Hazel Dev, and it's fast enough, I feel, and it's easy to use and it's great. And more importantly, it doesn't have any dependencies really. It's all kind of like self-contained in here, because what I did notice was I think I used another YAML library and it included parts of Boost and other libraries, and that's just too much. Like I don't want any of that. There's so much extra stuff on it. It's so heavy. I don't really care for that. So instead I'm going to be using this one here. So I've just added a pre-make file to it, just like I've done with IMGUI. This is the pre-make file. It's super simple. I mean, it's very straightforward to compile this. You just need to, include the CPP files for compilation. I've also included the header files so that they're part of the project. And then finally, include as an include directory, and that's it. It's that simple. The rest is literally copied from the IMGUI pre-make file. So to add this as a submodule, as always, we just have to go to like, the directory, right? I'll open a command prompt here. and I'm just going to type in git submodule add. That's the link to the submodule, and then we want to add it to Hazel, I think, / vendor. Now, this is another thing that you might want to think about. Do we want this to be inside Hazel or Hazelnut? Well, whilst YAML is predominantly going to be probably used by just Hazelnut most of the time, I still want to make it possible to serialize into YAML for runtime. The reason is that is potentially going to be really easy for debugging, and it's also going to, because remember, Hazel is not just a game engine, it can just be a anything engine really. It can be used for a lot of different applications. You know, if we're creating a new application that isn't Hazelnut, we probably want to support YAML serialization and deserialization. But more importantly, what if we just want to put together a little graphics demo and we want it to be really easy for a person to modify which model file it loads, for example? Well, if we just have like a little model viewer app or something, some kind of weird sandbox, right, that opens a YAML file, someone could just open the YAML file inside Notepad or Visual Studio Code and change the path to be something else. So that might be something that we want to support. Like, we could ultimately use the YAML file as almost a configuration file that's human editable without having to like open Hazelnut. And that could be useful, obviously, for a number of cases. So that's why I want to make this part of Core Hazel instead of being part of Hazelnut, just because I think that it definitely has a wider use case. So I think that's the syntax: git submodule add that, and then the path, which is Hazel vendor. Hopefully I'm right. I think it's actually the other way around, maybe. Ugh. Okay, what have I done? Hazel vendor, and then I might have to do that. Yep. Because that's the actual clone directory. My bad. Okay, there we go. So it's done. It's now a git module. It's now in here. Fantastic. Now, what do we have to do to actually get it to be part of our premake file? Not much. I mean, honestly, all we have to do is make sure that we have an include directory for it, which is actually in the other. We'll add that in a minute, but that's actually in the premake file. It's in the solution directory. YAML underscore will have to go with CPP because it can't be a dash in this case. Files to include, there's nothing changes here. Links, we're going to link, obviously, YAML CPP, this time with a dash. And I think that's really all we have to do here. Oh, and we want to add it as an include directory. We've done an include directory. My bad. Okay, so back here, we'll open the premake file as part of the root directory, the solution one, that actually sets up the workspace. And we'll have to add YAML underscore CPP here, which is just vendor YAML CPP, and it's also got an include directory. And then finally over here, so that it actually shows up as a project under our dependencies filter here, we want to have Hazel vendor and YAML CPP. I think that is it. And this will obviously include the actual premake script. I think that's it. I'm not sure. I'm not referring to my diff for this, so hopefully this is correct. Let's go scripts. Let's rerun this script. And then if we reload this, not only should we have YAML CPP up here, which we can now right click and build, we should also have, excuse me, we should also have it linked to Hazel, which is great. So let's just give that a build, make sure everything works. I mean, we're not using the code yet, and we can actually start on this serializer. So how do we write a serializer? Well, the way that I like to do this is, of course, as this entire series is completely just my preference. You can write your own engine. That's what this series is here for, just to show you how one might approach writing an engine. I don't like to add serializers to the actual class that is being serialized. So I mean, mostly this is going to be serializing just the scene class. Everything that we need is going to be inside scene, but I don't want to add a little serialize function. The reason is I picture serialization as an external thing, and I like to separate it out into an external serializer class. That's usually how I do things. It depends on the size and the scope of serialization. You can imagine that a scene is quite complex, right? It's quite complicated to serialize. It's not that straightforward. And because it's so complicated to serialize, we might want to separate it out into a new file so that it's actually just, clean. And when we're actually, caring about the runtime behavior of our scene, which is also going to be quite large in the future, I don't want to have to be, stumbling through so much serialization code. So because of that, I'm going to, under scene, make a new item here, and it's going to be a scene serializer. So I'm going to do scene serializer. Now this is going to support obviously both serialization and deserialization. So we'll add that like that. We'll include the PCH as well as the scene serializer file like that. Namespace Hazel as always, and then over here we can start on actually implementing our scene serializer. So I'll include scene because obviously it needs that. That's what it's going to be serializing. And then we're going to have a pretty simple, straightforward class here that, much like our pattern of taking inside the scene hierarchy, is how we take in like a context in the scene hierarchy panel. We have like a context, which is an actual scene that we can set over here. The same way we're going to be constructing a scene serializer that takes in a scene, right? So this will be scene serializer, and then we'll do const ref scene, because we don't need to copy and increment the ref count here. Const ref scene, right? That's the thing that we're serializing. And of course, it's going to store it as a member, and that's where we're going to copy it and increment the ref count. All right, and now we just provide some functions. So serialize to a file, so const std string file path, and then serialize, and we'll call it serialize runtime. So this is the part of the serializer that's going to serialize into binary instead of YAML, whereas this will basically serialize kind of, I don't know, you could call this serialize text, serialize binary, but I'm just gonna kind of call it like this maybe for now. Deserialize. So deserialize and deserialize runtime. Again, both are going to take in file paths. That's the entire API. So the idea is this is a very, very light stack kind of constructible class here that we provide a context with. It stores that context, and then you can call these functions however you like. So you could store it. You don't have to store it. You can just instantiate a new instance of this class really easily, really quickly, and then just call a relevant function on it. And that way, like you don't have to have some kind of weird static floating thing that like a static function somewhere that's floating that has to take in a scene and then a file path and all of that stuff. It's really quite simple to work with, and I do really like this API. Okay, great. So now let's create the method implementations. And then specifically what I'm going to do here is immediately for all of this deserialized stuff, just add a core assert. Just add a core assert here that says that, well, I'll just do core assert false and just add a little comment that says not implemented. And in fact, I'm gonna change the deserialization to be booleans. I might do that. I don't know if I'll do that with Serialize just yet, but because obviously what this does is it deserializes into this scene that you provide it with. So in other words, if you were loading a blank scene, you would make a new scene object yourself and then pass it in here. This is also nice because it means that the deserialize function doesn't also have the job and the responsibility of allocating memory for a scene that can be done externally. Then you just give it the ref and it will deserialize into that existing scene. Which in this case, if you were loading a blank one, it would just be like a new scene that you've just created, fresh, it's empty, and then you pass it into the deserialize function, or rather into the serializer, and then you call the deserialize function on that. Now, so let's return false here for now because it's not implemented. So deserialize runtime and then serialize runtime as well. We'll just make sure that we assert that just in case they're called so that we know that this is not implemented yet. Okay, cool. So with the serializer, with the constructor, all we need to do is set the scene. So we've got the context now. And then finally, we can think about serializing everything. So we'll include our YAML file here. So YAML CPP, YAML, just like that. Now I forget our convention. I think we've said that. I guess if it's outside of our current project, we use angular brackets like that. So I guess this should appear like this, because I wasn't sure if we wanted it to be like that if it's outside of our project or outside of the whole solution. Because obviously this source code is in fact all available to us inside this YAML CPP project. Okay, anyway, we've included YAML, so now we need to serialize. So as I mentioned, I am going to be copying and pasting some stuff because it's going to be way too long. The way that I've implemented this is basically like this. Let's copy the first little bit here, and I will explain it. So two quick things. Let's go back to the scene class, we need to add the serializer as a friend, because obviously we need to allow access to the serializer to go into our deepest, darkest secrets, which are like the registry itself and all of that stuff, since it needs to actually serialize us. And then also, we might need to include some other stuff, but we'll see. Okay, so what does this do? Well, it's really simple. Again, this whole process is so simple, right? We create a YAML emitter. This is using the YAML CPP library. We begin a map, because this whole file is really going to be a map, right? And then I have a key value here, which is a scene name. Now, we're not storing a scene name now, as far as I'm aware. Probably something we want to do. So I've just put like name goes here, kind of here. So this is going to be like the scene name. So we might even call it something like unnamed scene, okay? Or maybe like untitled, because it's a bit shorter, okay? So this is where it would go. That's our key and value. I like to actually write key values like this, so you can just keep kind of outputting stuff into there. So this is the key, this is the value, great. With entities, instead of having the value be like a normal thing, in fact, I might also collapse this. Instead of the value being a normal thing, the value is actually a sequence, right? So a sequence is essentially like an array. I think it actually is an array, and we'll look at what this looks like in a minute, obviously, when we actually serialize it. But we begin a sequence, and now we go through every entity, and if it's valid, we serialize it. Then we end the sequence, we end that array, we end the map, which is like the whole kind of file, right? So entities is the key, the value is the array. And then we just output it into the file using OFStream, right? So really, really simple. I guess I'll just include fstream. I'm not sure if we need to. We might, excuse me, we might be including it from some other places as well. So serialize entity, this can just be a static function, doesn't really need to be a member. So we'll do static void serialize entity. We'll take in a YAML emitter, right? Because obviously this is like our output here. And then we'll take in the entity that we're trying to serialize. And now obviously this function works. So how do we serialize an entity? Well, let's begin really simply, and then we'll kind of run this and you'll see how it changes. So this is the first thing that I did. Entities should have GUIDs, right? Or UUIDs, right? Universally unique identifiers. The reason is that there are a lot of reasons why we want to have like a proper ID. And this isn't like I'm not going to get into it now, but essentially we need to have a proper ID per entity so that we can properly identify it, and it should be like a globally unique asterisk ID, because like it's possible that these IDs get created like at, you know, across different like computers, and essentially that we don't want like a global authority handing out incrementing IDs. We want them to be random, because that way they can get created wherever, whenever, and it's obviously extremely unlikely that it will conflict with an existing entity. We don't have that yet, so that's why we have this random string of numbers here. To do entity ID goes here, okay? And as mentioned, I worked all of this stuff out during the live stream. So that's basically, so we begin a map called entity. That means that we also have to end the map. So I like to add a comment here, specifying which map specifically it's affecting. So that way, when we begin and end, and I don't know why I didn't do that. It should be like that, I guess, because it's a long line, but whatever. So we have the entity ID now. And then what we're gonna do is actually, I guess, have, because we've begun a map now, so the entity is going to be equal to this, which is just like the ID. I could have called this ID, but entity just makes it a little bit more readable. And then we have to go through everything and serialize everything. So as an example, let's serialize something really simple first, the tag component. So let's include components, because we need to be aware of all of them. So if we have a tag component, which obviously we should, but I've just got an if statement here, might as well, for safety, then we will grab our tag component key, right? So this is like basically saying, hey, this is a tag component, and then I begin a map which stores everything that the tag component is. Now in this case, a tag component is just a tag, so I could have just, you know, essentially made this code look like that, right? Tag component equals tag, right? But for consistency's sake, because I'm trying to keep this consistent with other components, obviously that will have more than one data field to serialize, I've done it a little bit differently, okay? Or at least I've done it this way, even though for this example it might be overkill. And that's our tag component, right? And then so what I'll do is obviously end the map, which I should have done here. And I think that's it. So this is a very, very simple example of just serializing a single component from an entity. But based on this, you should be able to implement the rest yourselves. Obviously, I'll do it in this episode as well, because I have to. But if you want a little bit of an exercise, obviously feel free to just do the stuff. There's always stuff flying around. Why? Anyway, sorry. Feel free to take this as an exercise and an opportunity to maybe do some of your own programming if you want and implement the rest of these, because there are certain things that are more complicated to serialize that we will have to do, right? But that's going to be fine. Like like for example, things like, VEC4s or VEC3s or the GLM math types, we obviously need to provide custom code to serialize that because YAML doesn't know, YAML CPP, the library, doesn't know how to serialize that stuff. But we'll get through that. That's it. This is as simple as it is. So let's see what we end up with this kind of YAML code. How do we use this? Well, I said it was really simple, right? So all we have to do is inside editor layer, let's include scene, Hazel/scene serializer, right? We'll make our scene using C++ code, which is what we're currently doing. And then maybe like at the bottom, I'll do scene serializer, right? Which takes in our scene, which is our active scene, I believe. And then it just does serializer.serialize. And then let's go to assets, scenes, example.hazel. Okay, that's it. Let's run this code and we'll see what we get. And it's already an error. Let's go back here and return false. Deserialize, we are actually going to implement today. So not too fussed about that. Okay, so nothing appears to be different, but obviously now what we should have is inside Hazelnut, we should have a little file inside the Hazelnut directory, I should say, called, it should be in assets. Why isn't it here? Assets, scenes, example. We might need to actually create the directories ourselves. I've forgotten how to do that. Let's see what's happening here. Yeah, so it definitely should be, definitely should be written. Let's just test this out quickly. Let's add a folder called scenes and see if that works. Yeah, there it is. All right, so we'll need to add some flags probably to the OF stream so that it creates all the directories for us, but we'll do that a bit later. So we have example.hazel, and if we double click on it, this is what our YAML file looks like. So we have scene, untitled, right? We could probably get YAML to add a little comment at the top as well that specifies like what kind of file it is. We can do that if we want. But then we have the list of entities here, the array. So we have the entity ID, and then a list of components. So we have tag component, and then the tag is camera B, and then we have camera A, and then red square and green square. So you can see how simple it is to just serialize some data. Let's go ahead and add in the rest of the components. So as I mentioned, I've already done this before during the live stream, which you can find on twitch.tv/Cherno or on Patreon if you want to watch the rerun, we'll say, the recorded version. But over here, if I paste in the rest of this code, let's kind of go through it. So it's really simple, obviously. It's the same thing. So for the transform component, we obviously output the transform component as a key. Then we begin the map, we get the transform component, and then we just output everything the transform component is. So it's a translation, rotation, scale. We simply just output that as translation, value, rotation, and then the value, and then the scale, and then the value. Now you'll notice this isn't working because we actually need to add an overload for this operator to take in a vec3. Because this is a vec3 and it's a GLM type, and YAML CPP, the library, doesn't actually come with operators for GLM, understandably, because it's a different library. It comes with a lot of operators for default types, but not for this. Then we have the camera component. This is like the big juicy one. There's a lot of stuff here. So there's actually kind of two things in this camera component. There's an actual class called scene camera, which contains a whole bunch of data that we need to serialize. And then there's also primary and fixed aspect ratio. So what I've done is I've actually, instead of just outputting them as key and values, I will actually begun a map inside this map, which is the camera class. So the camera class stuff is under its own kind of section. And then there's like projection type and everything here. And of course, this projection type, which is actually an enum, right? I'm just casting it to an int so that it gets serialized. And that's it. That's the camera component. Sprite render component, same kind of thing. We're just outputting the color because really all it is a color. Once we have textures and stuff and assets, we'll probably serialize assets by their IDs and their goods. And we'll cross that bridge obviously when we get there. That's it. So these obviously don't work. So how do we make them work? Well, we need to overload the I guess bit shift left operators. So I do that by just going to the top of the file and pasting these two in, one for the vec3, one for the vec4. Really simple. We basically just add the operator with whatever type we want. And then we, in this case, I'm using flow, which basically means that instead of outputting it as like a key value thing for X, Y, Z and everything like that, it's going to actually output them like this, right? For a vec4, or like this for a vec3, which obviously is just going to take up one line. It's going to look a lot nicer. That's called flow. So I'm doing that, and then we have the begin and end sequence. That's it. Really simple, and now obviously this works. So rerunning the exact same code again now. And opening this, we now have a fully serialized scene. How simple was that? I mean, I know I copied and pasted like all of the code, but it is really simple, right? So yeah, really simple. Okay, and then we have everything that we need here, obviously. So if we go through this loosely, just so we see what's here, we have a tag component, obviously the transform as a flow. That's why you see it like this. Camera component with everything serialized. And then we have our camera A, which is in fact our primary camera. So it's set to true. I think, yeah, we have all the details here. And then our sprite renderer with our kind of red color, which is our red square. Really simple. Okay. And now finally, to deserialize this, we need to basically do the reverse of this. It's also really easy to deserialize, and I will also copy and paste some code, but I'll take you guys through it in the same kind of fashion. Just increment. By the way, let me know what you think of this format where I'm incrementally like copying and pasting code. Obviously for people who are regulars on Twitch, they see me go through this for hours and type it out and work out what it's going to be in the first place. So they might be fine with it. But for those of you who are exclusively watching this series on YouTube, let me know what you think. And if this is like, I mean, I imagine this is pretty easy to understand. I mean, I'm going through all the code and not copying 200 lines all at once. But if there's any problems, let me know. Obviously this series is for you. It's not for me. I know how to do this. Okay, so deserialize. So the first step is going to be, and I've added some logging code here as well, just so that we can keep an eye on what's going on. But we basically open up an input file stream, and then into a string stream, I'm passing in the buffer from the file stream. This is just the complete buffer of all the text. And then I'm passing in this string from there into YAML load, which is the YAML CVP library, that function that actually will contain all the data now. And then we have a series of nodes. So if the scene node is not present, then I'm just return false, because it has to be in the wrong format. Because we have to have a scene node. That's what all this is really, right? There needs to be a scene node, and if there's no scene node, then what is going on is not the right format. Then what we're going to do is actually get the scene name, which is what we see here. And then we need to get the next node, which is going to be our entities node. So the way that we retrieve a node, which is just going to be a YAML node, I'm just using auto here, right? But we basically go to this is the root node. And then that node is going to have a node called entities. And you can tell because here it is. It's on the root. It's not like a child of any other existing nodes. And it's called entities. So under the entities node, we can now check to see if that node is present. And if it is, then we have entities that we need to deserialize. So that's what we do next. So how do we loop through all of this? Pretty simple. We just do for auto entity in entities. And now we have each entity node here. So from here to here, basically, we have access to entity, tag component, transform component, camera component. And we can just simply get them by just being like, hey, entity, camera component, is that present? And if it's present, then, well, we can do something with it. And that's going to be our strategy. Really simple. And also really kind of error proof, right? Like as in, if the node's not present, we don't deserialize it. So it's not like it expects something to be present. It's very flexible. So the first thing we'll do is try and get the ID The ID, obviously, and I'll copy both this and I guess the tag component as well, but the ID is a to-do thing at the moment. This would be the universal unique identifier, the UUID. We don't have one at the moment. It's just serialized as this blob. But I do want to, where is the blob? Here's the blob. But I do want to already kind of just create a place for it because that's important. And then, then we'll try and retrieve the tag component. So we'll get the tag component. If it's present, we'll get the tag as a string. And now we've got a name for our entity, which is pretty exciting. Okay, so next we probably need to actually create an entity. The whole point of this is now we're deserializing a bunch of entities. We need to add them to our scene. Same way as we looped through all of the existing entities by using the registry, like each function here, right? With the entity ID. Over here, we need to actually create entities. So how do we do that? We're gonna make an entity called deserialized entity and set it equal to mscene create entity. And then the name, obviously, now that we have a name, that's why we wanted to do this first, we can create an entity with that name. Now, eventually we'd probably also pass in the UUID and do like create an entity, with UUID or something like that. But we don't have one, we don't have the function yet, and we don't really have IDs. So we're not gonna, we're not gonna worry about that just yet. So the next step is gonna be the transform component. I'll just copy and paste it to show an example of a transform component happening. Really simple. We just get the transform component, same as the tag component. If it's present, then let's actually set the values. Now, in this case, we're doing get component because entities always have transforms. We can assume that it's present because when we create an entity, we also add a transform component to it, right? That's what happens here. For all of the other components though, instead of get, we'll have to do add because they're not going to be present. It's a brand new entity. We could write a function called get or create component or get or add component. So what that would do is obviously just in here, it would just check to see, hey, does it have a component? If so, return get component, otherwise return add component. Easy. Translation, rotation, scale, we deserialize them. Now, I think we're gonna need, if we try and compile this, I think it's not gonna work. Because there needs to be, if you read this properly, there needs to be a decode function for each of these types. So I've already done that, and this is from Hazel Dev as well. But basically what I've done is, I've done this for just vec3 and vec4, it looks like, inside this. But this needs to be inside the YAML namespace, and I've just added these conversion functions. So encode and decode. So this will actually go through these custom types, such as a vec3, and actually either push back everything it needs into the node for encoding, or retrieve the primitive types from it, right? So this is like the result that we're populating here. And then we're just going to basically get node 0, 1, and 2 out of the sequence that we've previously encoded here, 0, 1, and 2, out of this sequence, which is essentially an array that's in like a flow format, but that's irrelevant. And it's going to actually set the vec3 to those values. So just adding some deserialization and serialization code for all of these custom types. Very simple, and now that should work. Okay. So the last step is basically the rest of the components inside Deserialize. So we've obviously just added the transform one, which is over here. Pretty straightforward, I think. Again, we're just getting the component, setting the fields, really easy. And then camera component, and then the sprite render component. I'll do them both in one go. This is exactly the same as what we had before, right? With the camera, we just add a component instead of get it because it's not going to have a camera by default, and this is obviously only if it's present inside the YAML file. So if it is present, we're just going to get the projection type, which will be, so we're inside camera now, and then we're going to get the projection type because we're inside the camera node here. We'll get it as an int, but then we'll cast it to our enum class, and that will of course set it to whatever it needs to be. Now we will have to fix up some stuff here because this won't work as expected potentially. Has some bugs with the camera stuff because of our camera code, not because of the serialization. Because when we actually set the projection type for a new scene, it recalculates the projection, which relies on the aspect ratio being set from the viewport size, but the viewport size is, well, 0 by 0 because it's a new scene and it may not have had its viewport size set by IMGUI kind of panel code just yet. So we need to make sure that we catch that case as well. Anyway, very straightforward. Sprite render component, deserialize it as a vec4, and then set it into the component when we add the component. Really easy. I don't know why that code is there. Must have copied and pasted the transform component where I was writing it. All right. So next step. If this all succeeds and we're not like returning false or whatever, we'll obviously return true. And then I think that's it, to be honest. So now what we should be able to do is let's just get rid of, we should be able to deserialize our scene. So if we just surround all of this by an if 0, right? I mean, we're not doing the script stuff yet. We'll talk about that another day because that's like native script stuff, so it has to be handled a bit differently. But all of this red square stuff that we used to create, if we just, let's not serialize anything so that we don't override it. But let's just launch this. We should get just a blank empty project. There we go, right? Now, if we actually do deserialize, we should hopefully see everything. The camera stuff might not work. We'll see how that works out. Oh, it did. Okay, there we go. So we've got our scene. You can see our deserialization code worked and everything is in the right place. So yeah, that's that. So what we can do to test this out a little bit better, and I will, next episode, we'll actually properly write this stuff. So for now, I'm going to keep it really loose, but next time we'll have like open file, save file dialogues and stuff. We'll do that in the next episode. But what I'll do for now is maybe just under this menu bar, we might as well do it here. So we have the file menu. Let's add 2 more things here. I won't call them save and load or save and open for now. I'll call them serialize, deserialize, because that's literally as simple as it's going to be. So serialize and then deserialize. Okay, and it's just going to be hard coded to that one path. Keep stuff really simple. So again, really easy to construct this stuff, right? So inside deserialize, I will just call this code, and then over here, a simple construction, we'll just call serialize. Really, really simple. That's the whole point. Okay, so blank scene, file, deserialize, got a perfect scene. Let's maybe move this green square out of the way so that we can see our red square as well. And then I'll serialize this, and then I'll deserialize it. Oh, and this is one more thing we have to do, but this is more, this isn't really the serializer's fault, it's the editor layer's fault. But if we open this now and we deserialize it, we should see the 2 squares in their different positions. Now, at the moment, if we deserialize many times, it's going to keep adding everything into the same scene, right? So now if we move the green square, you'll see there's another green square. And that's because obviously we're not actually making a new scene, we're deserializing into an existing scene. So you would fix that by actually making a new scene. But then when you do that, you have to reset the context. And as I mentioned, there's going to be some problems with the camera because if you look at this code over here, well, as soon as we deserialize, it's going to want to set the camera projection, but it can't do that just yet because the camera projection is dependent on the, where is that code? It's dependent on this viewport code stuff, the active scene on viewport resize code that hasn't run yet. So we'll run into some problems there. But anyway, for the most part, you can see we can now launch this and actually deserialize an existing scene, which is pretty cool and not really that much work. Okay, so that is the end of this episode. I hope you guys enjoyed. If you did, please don't forget to hit the like button and also help support the series by going to patreon.com/thecherno. You'll get access to all the past recorded live streams as well as Hazel Dev, which is where this code has existed for like the last year or half year or whatever, because obviously we've been saving scenes there for a while and that's where everything's kind of coming across to. But thank you guys for watching. Next time, as I mentioned, we're going to actually add a proper like save and load, save and open file dialog and all that stuff so that we can actually save this to a custom path and load a custom file and not have to just always obviously write to and read from the example.hazel file that we're doing here. Thank you guys for watching. I'll see you next time. Goodbye.